Is about multiplying and dividing radical expressions. According to our book, Multiplying Radical Expressions, if the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b is equal to the nth root of a times b. Here's an example. Multiply and simplify if possible. The square root of 2 times the square root of 8 should equal the square root of 2 times 8, or root 16, which we know to be 4. The cube root of negative 5 times the cube root of 25, well, we can multiply those together as the cube root of negative 125, which we should be learning that that's negative 5. 5 times 5 times 5 is 125. Three negatives multiplied together give us a negative. The square root of negative 2 times the square root of 8. We're going to run into a problem here because negative 2 is not a real number under your square root. The square root of negative 2 is an imaginary number, so we should be done right there once we realize that. But if we carry this further, you'd see the square root of negative 16, which is still an imaginary number, and you'd want to stop. You can't multiply non-real numbers this way. They have to be real. Dividing radical expressions, if the nth root of a and the nth root of b are real numbers, and b is not 0, then the nth root of a divided by the nth root of b is the same thing as one big root, the nth root of a over b. So in this case, if we're trying to simplify the cube root of 32 divided by the cube root of negative 4, we could just say that's the cube root of negative 8, because 32 divided by negative 4 is negative 8, which is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. Similarly, the cube root of 162x to the fifth over the cube root of 3x squared would simplify to the cube root of 54 over x cubed. Let's see where the 54 came from. Well, 162 divided by 3 is 54. It goes in there nice and evenly. And if I have x to the fifth in the numerator and x squared in the denominator, and I just take two x's out of each, that reduces that x to the fifth over x squared down to an x cubed. Cube root of 54, let's see, 27 goes in there. 27 goes in there twice. The cube root of 27 is 3, so that's going to be good to know. And the cube root of x cubed should just be x. So the cube root of 27 is the 3. The cube root of x squared is just x. 27 times 2 gave us the 54. So 3x cube root of 2. Let's try some of these on our own. Next example, we're asked to multiply and simplify if possible. We've got root 6 times root 2. Sometimes I like to simplify a little bit first. Notice that root 6, I see this root 2 sitting here. Notice that root 6 is the same as root 2 times root 3. Root 2 times root 3 is root 6. It's kind of using that property, multiplication property, the other direction. What should we get if we multiply root 2 times root 2? Well, that's right. We should get a 2. So this whole thing just simplifies to 2, and then the root 3 is stuck inside, so 2 root 3. That's the answer they're going to get. 2 root 3. Why don't you try this next one? Pause the video, try this real quick, and then when you're ready to check your answer with theirs, press play. Okay, let's see. Did you get their answer? Did you get 2 root 6? This, again, you can break apart the root 12. There's a root 2 sitting here. We know that root 12 is the same as root 2 times root 6. Root 2 times root 2 is the 2, and the root 6 doesn't simplify. Let's move on a little bit. We're doing fourth roots here. The fourth root of 7 times the fourth root of negative 7. Well, right away, we've got a negative number inside an even root. That's imaginary, so that will not simplify. Let's see if there's another one here that does. Oh, here we go. A negative number inside an even root. That's imaginary. It will not simplify under real numbers. If we go to use the imaginary number system, we're okay, but not under the real numbers here. Let's go on to another one. All right, here we are again. Simplify the cube root of 128a to the 13th, b to the 6th. Assume that all variables are positive. Let's see, cube root, a perfect cube that goes into 128. I'm thinking 64. Cube root of 64 is 4. So let's break this down a little bit. The cube root of 128 should be the same as the cube root of 64 times the cube root of 2. 64 times 2 is 128. The cube root of 64 is 4. So that part's going to be 4 cube root 2. Now let's look at the cube root of a to the 13th part. The way I like to do these is real simple. I just ask myself, how many times does this number divide into that number evenly? Well, 3 goes into 13 4 times evenly with 1 left over. What that means is I'm going to have a to the 4th come out, and I have the 1 left over. He just stays inside. So I've got part of the answer here. I've got part of the answer here. Then finally we've got b to the 6th. So I've got the cube root of b to the 6th. How many times does 3 go into 6 evenly? Twice with none left over. So I'll just get a b squared out. There's the other part of the answer. So my final answer should be 4. A to the 4th and b squared are also on the outside here. And then what's inside the cube root is a 2 and an a. My final answer. Let's see how that compares to theirs. And that matches up. 4a to the 4th, b squared cube root of 2a. The font here isn't looking so good on the powers, but that's what they are. Why don't you go ahead and try this next one. Pause anytime you need to. If we're going faster, feel free to pause, rewind, watch it again, whatever you need to do so that this works for you. Okay, so you go ahead and try this one. When you're done, and pause the video right now, but when you're done, restart the video, check your answer with theirs. Okay, let's see how you did. Did you come up with this answer? These are powers, a squared, b to the 4th, everything else should match. Let's give you another one here. Let's regenerate that. All right, we'll let you do this one. These are powers, a to the 7th, b to the 9th. Go ahead and pause the video here, try that problem. When you're done with it, press play and check your answer with theirs. Let's see how you did. Did you get 2a squared b cubed times the cube root of 3a? If you did, you're good to go. Let's move on. Let's try this one. Cube root of 162 divided by the cube root of 2. If we just follow the rule for dividing here, we're just going to take 162 divided by 2, which should be, what, 81? Can you think of a perfect cube that goes into 81? Remember, our perfect cubes are 1, 8, 27, 64, excuse me, and 125. Well, 125 is too big. 64 doesn't go in. 27, I think, goes in there 3 times. 27 times 3, I believe, comes out to 81. So let's give that a shot here. This would be then the same as the cube root of 27 times the cube root of 3. 27 is our third perfect cube, so the cube root of 27 is 3. So we should have 3 cube root 3. Check our answer up here. There it is, 3 cube root 3. Why don't you try one of these? Again, go ahead and pause the video, try this. When you're ready to check your answer with theirs, press play. All right, let's see how you did. They got 3 cube root 3. Is that true? I don't believe that. Let's try that. Let's see. 405 divided by 5. 405 divided by 5 is 81. What do you know? That's the problem we just got done doing. Cube root of 81. We just did it. We know that's 3 cube root 3 because we just did it. Let's go on. Same type of stuff, except it's a 4th root. Let's do this. 400 divided by 5 is 80. So we got the 4th root of 80. Now we're dealing with 4th roots. So let's look at 1 to the 4th would be 1. 2 to the 4th. Let's see, 2 squared. This is the same as 2 squared times 2 squared. 2 plus 2 is 4. So 4 times 4 is 16. And that'll work because I know 16 goes into 80. So let's try that. It's the 4th root of 16 times the 4th root of how many times is 16 going to 80? It's 5. So this all simplifies to the 4th root of 16 we know to be 2. So it's going to be 2 4th root of 5. And we'll check that up. There we go. Why don't you try one of these here real quick? Let's get the recording going again here. Let's see, when I do 240 divided by 5, I get root 48. I know that 48's a multiple of 16. That's root 16 times 4th root 3. So this should come out to 2 4th root of 3. Let's check our answer with theirs, see how we did. There it is, 2 4th root of 3, same thing we just got. Let's move ahead. We can do these. We had an example earlier. This is different. Rationalize the denominator. Assume that all variables are positive. Well, to rationalize the denominator means to get any radical symbol you see out of the denominator. We have to make that a rational number. So this is an irrational number when we have a radical symbol down there, so we need to rationalize that. In order to do that, we've got to get a perfect cube down here. And the easiest way, it's not always the smallest number, but the easiest way is just to make sure we have 3 of these cube root 11s. So what's 11 times 11 is 121. So if we multiply by a cube root of 11 squared, it's the same as multiplying by the cube root of 121. So the bottom is going to be 11 because I just multiplied by 3 11s and took a cube root. The top is going to be a pretty good sized number here. It's going to be the cube root of 1089. Now I know that 9 is 3 times 3, and I know that this is 11 times 11. So that gave me this 1089. I know that there's not 3 numbers multiplied together that are going to give me the 1089, because here's the 4 numbers that do it, and there aren't any 3 that match. Therefore, that should be my final answer right there. They have a wrong answer. I remember this problem now from years past. They don't calculate this right. That number doesn't come out right. They just multiplied by 111 instead of 2 and have a wrong answer. Our answer is right. You can verify that with Wolfram or some other application online if you'd like, if you don't believe me. Rationalize the denominator. Oh boy, this one's got a mess. Let's first reduce. Let's reduce everything we can. Can't do anything with the 5. It's going to stay put. The 6 then will also stay put. I have x to the 8th on the bottom. I have x squared, or excuse me, on the top. I have x squared on the bottom. That should leave me 6 x's on the top after I reduce. I'll take 2 out of the bottom and 2 out of the top. And then with the y's, I've got 9 on the top and 4 on the bottom. Well, if I take 4 out of the bottom and 4 out of the top, that'll just leave me with 5 in the top. Therefore, to rationalize this, I just have to multiply by another root 5, because root 5 times root 5 is just going to give me 5. That's rational. It's outside the radical. I only need 2 of the same factor when I'm dealing with square roots. On the previous problem, I needed 3 of the same factor because I was dealing with cube roots. Let's multiply here. 5 times 6 is 30. And so I've got x to the 6, y to the 5th. I believe they do this one right in the software, so let's see if they match up with us this time. Oh, I didn't finish off the x's and y's. I stopped too soon, so got a little hasty there. Let's go ahead and finish that off. This is a square root, so it's like there's a little 2 here. I have to ask myself, how many times does 2 go into 6 evenly? That would be 3, so I'm going to get an x to the 3rd out. How many times does 2 go into 5 evenly? Well, that is 2 with 1 left over, so that's going to leave a y inside. And that's how they got their answer, which theirs is right this time. Mine was wrong. I stopped too soon. All right. If you need to try more of these, there's plenty of odds in your book in the section, and you should probably go ahead and do those if you're not feeling comfortable with them quite yet. Back into here, I believe we have reached our conclusion here. There it is. Yep, that's our learning target. I'll see you in class. Turn in the book. I had you in 5th.